Okay, okay. It should be good. It should be good. Right, so now we have our problems. Okay, so it's Codeforces around 702 div3. It shouldn't be difficult, but I don't have much time, so we'll solve what we can solve in time that I got and maybe upsolve later. So in problem A, dense array polycarp calls an array dense if the greater of any two adjacent elements is no more than twice bigger than the smaller. Okay. Yeah. You're given an array. What is the minimum number of numbers you need to add to an array to make it dense? Okay. Oh, we actually have test cases in this problem. Yeah, typical for Codeforces actually. I can't. Sorry. Now we got our array, and actually, what I would like to have is like a distance function. Okay, so it's like every pair of elements, adjacent elements, it requires some number of elements to be inserted between them, potential 0. So what we're gonna do is the following. So we'll have some sort of answer. And we're gonna calculate the distance between every pair and just add it, and then print the result. And how to calculate this thing? Well, you can actually do it by hand. Or, I mean, you can do it, it's like base to log of quotient rounded down, I guess. But we again do it by hand. So if x is greater than 0, then we can swap x and y. If x is greater than y. My typical classmates, they like never write when it's not a contest. But then when it is, they just all want something of me. Okay, so so distance is 0, then we're going to return it. Yeah, but like constraints are not the issue of the problem. While 2 times x is smaller than y, x should get multiplied by 2, and we should increase the distance. Yeah, and we can do it the fancy way. We should be good to go. But of course, we'll test our solution. Yeah, typical me writing in the last problem instead of the first problem. Right. How is it wrong, actually? Oh, of course. 512103. Yeah, I think it's correct. Like constraints are lost, so we don't have to worry about that. How long is the queue? Okay. And problem B, balanced remainders. We're given a number n which is divisible by a string in array a of n elements. Want to do something with that array? We can increase any element by 1, choose index, yeah, okay. Let's not by C0, C1. So choose the number of elements from an array that have reminders 0, 1, 2 when divided by the number 3 respectively. Let's say that the array A has balanced remainders if they are equal. Okay. And that's why n is divisible by 3. Okay, so we want to equalize these numbers, right? Good. How do we actually do it? Like, hopefully without some greedy style arguments. Yeah, I mean, like, well, actually, not like that. I keep forgetting how array is initialized, so. Are numbers positive? Do I have to? Yeah, I don't have to worry about that. Okay. Yeah, I want to do something like that. Yeah, I think like 3 cycles should be more than enough. Actually, I think 2 should be more than enough. But whatever. So if zeros, like, we know what number we want Ci's to be. So suppose it's greater than egg. And yeah, to the next mod 3. So obviously ops gets incremented by this, and this gets incremented by this. And of course, this gets decremented by this. If it's smaller, then we don't care because we are going to encounter such thing at some moment. And it basically means that we have to move out of the way. Like there's no way we are going to get rid of them without moving them explicitly from that cell somewhere. I think we actually can make it work with 6 instead of 9, but just to be extra safe. Where exactly? What? Yeah, you know what's about it. I could just do this, right? Stop. Please stop. Right, because here of course I want this to be mod 3 as well. Almost here, almost there, I should say. Nope. 3130. Looks like a legitimate transfer. Is it key long? Nah, okay. Problem C is sum of cubes. We are given a positive integer x. We want to check whether the number x is representable as the sum of cubes of 2 positive integers. Well, okay, then we can do it in cube root type, I guess. Right, okay. No, it's not going to be anywhere close to time limits. I'm just thinking. This is incorrect already. Now we are much better. For some test cases, yeah. Wow, thank you. I can't remember seeing this notice, to be honest. Yeah, also interesting light we got going on there. That's because some buildings act a lot like a mirror at the sunset time. So what do we want to do? Like we actually, that's kind of, at least one, okay. It's one to overflow as next. Now the problem is, how do we take a cube root? You know what? I'm not trying to be smart or anything, but we always can do a binary search, right? But I feel like library should be more or less precise here. Okay, so we have just that. You know, like, it costs me nothing, but it's much safer, I believe, to check like that. I want to print a yes, and I want to break. Not break, but here actual break equals true, and we can actually, yeah, like we can break, we can. I think I can't reassign it. Oh, right, right. I think this should be within precision. Well, that's correct. I mean, we take we thought about cube root being approximate. We thought about having int64 keys where we should. And I think with this we are good to go. Okay. So in problem D, permutation transformation, we're this is usually a permutation. Okay. Polycarp was recently gifted a permutation of length n. Likes trees more than permutations. Understandable. Me too. I don't like permutations that much. So he wants to transform a permutation into a binary tree. He transforms an array of different integers in tree as follows. max is the root from that. So he transforms it into a heap, but like tree-based heap instead of array-based heap, right? That's actually interesting. Yeah, that's smart code, but I'm a bit busy, so your notifications go off as well. For example, yeah, I gotcha. Yes, okay. As is denoted by D with the depth of vertex V. For each vertex, find the depths. Really? Like with such constraints, I can afford brute force. Like obviously, a better way would be to have some RMQ data structure where M stands for maximum in this case. But who cares in these 3 rounds about RMQ, right? We just write a for loop and then we don't care. Which is kind of disappointing, but that's expected. It's actually right to with the lambda, so nah. Yeah, like that. What do we want actually? Also, we have an array depths, and then we're going to construct from A, which I guess will return nothing and will just fill depths. And we want to just and I'm trying to write it with iterators, so also I think it's actually a better way of doing this. So no, we don't know one. We don't want middle, right? We want just a max iterator, which is going to be nothing but max element. So we took it, and then, well, I must say if begin and not equals, and then and only then I want to actually do something. Otherwise, I'm completely happy with what I got. And I'm thinking we have like current depths, which is 0 by default. What do we want to do then? D of max is equals depths. Like to call build of begin. Max it not inclusive. Current depths plus 1. Build from max iterator. And current depths plus 1. This may not compile because it may want explicit types for iterators. Yeah. The point is that I actually I think I did not pass depths. Hmm? Oh, that makes a lot of sense. I did not thought about it. That's kind of annoying, actually. Yeah, I think that like this idea was better, but we have to be right. You know what? We are going to do it old-fashioned way. That's right. Well, that's exactly how we do it here. Um, yeah, that was a poor design decision on my side. From 3 integers, I believe. How do you like that wonderful syntax, which is not really wonderful? Oh, so still something wrong. Yeah, but it can't tell me exactly. D20 and D25. So understandable, understandable complaint. D25. A is captured. What? Done. Do you really? Do you really? Well, that was annoying. Either way, I think we are fine. Like actual number of operations is n squared times number of test cases, which is completely fine. Numbers are a permutation, sure. So they're relatively small and we should not experience issues on that side. Probably accidental victory. A championship is held in Berlin in which n players participate. The player with number I has AI tokens. The championship consists of n-1 games, in which are played according to the following rules. In the game, two random players with non-zero tokens are selected. If the player with more tokens is considered winner of the game. In case of a tie, the winner is chosen randomly. The winning player takes all the tokens. The last player with non-zero tokens is the winner of the championship. All random decisions. Oh, I don't want a probability problem, really. On D3E probability. What do you expect your people to know? Div3 users know probability? Or maybe, but I would expect something less difficult. So, championship winners will receive personalized prize. Therefore, the judges want to know in advance which players have a chance of winning, which is non-zero probability. Okay, so probability is relevant. Okay, now I'm satisfied. So you see we clearly can't simulate the game for every player. It's just too much. So actually there is, we can determine by a binary search what is the player who can actually win, and simulation will be done with something like yesterday multisets. Yeah, just bash everything with multisets. That's the purpose of that data structure, I often feel like. Come on. My keyboard does not want to cooperate. Or maybe I just should spend more time training how to type. And yeah. Well, we already seen yesterday, well, actually today it's morning if you count the release date, that you got to be careful with multi-sets of int64Ts. Yes, and this is not going to be a problem. How is that not turned off? Anyways. What sounds like a reasonable bounce on the winning number? This is. Let me think actually. Now the players are not numbered and we want to print their numbers in increasing order. So what we are going to do, we'll need pairs A indexed really? Okay, I guess we just have no choice at that moment. Yeah, I know it's not what you would like to see. Let's have it here. The ugliest way possible. Really. Like, we want to sort numbers, but at the same time, we want to keep their IDs because we will have to print these IDs in the end. With our constraints, we are happy with that. And we have to if metal is good, we'll define function good later. If metal is good, then lowest possible, or actually highest possible. No, that's incorrect. We are interested in this number, in the indices, right? So we should do just this. Maybe I should. Yeah, okay, like indices are always integers, values are like integers. So if not, if good, if this value is good, then high should get middle. Else low should get middle. we'll have to fill it in. Also sort. Okay, so the sum does not exceed, which is exactly what you want here. We can ignore the value, we can get the index from AI, the indexed. High is like always possible. Okay. It's at least high. Yeah, but what if we should have -1 here, signify that this number is never can win. Never can win. Okay. Yeah, I think it's okay. So winners push back index. No, that's the wrong index. That's wrong index. This index, then this index will push back. One sort indices and then print them. Okay. Now here. Can we really afford it? Let me think actually. Log squared of n. No, we don't need multi-set here. Like extra log can hurt actually in this situation. So we can start with AI middle first. That's how many tokens we got from the beginning. And then we start thinking. If sum is greater than or equal to AI, I first, well, obviously, if I is not equal to me, because we already have me, and sum gets incremented by AI first, else return false. Here however, nah. Okay, 41. Push back AI second, I guess. Oh, that's interesting. Well, first of all, I actually want to output this, but this does not matter. Oh, and I also want to print the number of players. Okay. Oh, because this condition always gets hit. Like this instead. 2, 3, 4, 1, 2, 3, 4, 5. I mean, sound legit. I have anything stupid here. That's an index, index, index. This is an index. This index and index, index, index. Isn't it all these are indices, so we are safe to submit like this? I should have tested it more. But sometimes even like this, you can get accepted. I think we are slow, actually. I check the standards real quick. Yeah, like all adequate people already solved everything. Let's have on F equalize the array. Polycarp was gifted an array A of length n. Considers an array beautiful if there exists a number C such that each number in the array occurs either 0 or C times. Polycarp wants to remove some elements from array A to make it beautiful. Okay. Oh, okay. So because number C is not fixed, the problem is not obvious. Is it actually? Suppose we sorted everything and just loop over all possible values of C, and all meaningful values of C correspond to all values of AI. And what do we want from AI? The number of operations? Not from AI, but from frequency array. Well, frequency array is not huge, so. This really feels like a div3 round. Like sometimes they have non-trivial ideas. Here we don't see any such ideas. Let me think whether I actually want to or I don't want to. I mean, I'll have to sort it either way. So, but I don't want to sort it like that. I want to sort on frequency, which actually corresponds to a different thing. We get our frequency map and we take its values. We can disregard the keys actually. Sorted values. What do we want now? Now we want to know prefix sums and suffix sums. Like we always can remove. All elements, right? We want we want both prefix sums and suffix sums. But suffix sum is like sum of everything. Oh, it actually does not match, right? Oh, it's How to win it. We got suffix sum, we just have to do it in reverse order. Now I actually will have to think for a moment. Obviously I want something like this, and then just prefix sum at I, let's say, decremented everything but this. Suffix sum at n minus I plus 1. Actually, at n minus 1 should be good. C is what? C is BI. Oh no. More like this. Okay, you know what? This has got to go because this is also present here. Minus C, it looks like. Times K minus I. Now that's not obvious, but I think we want something like that. That's the wrong file. Typical. What can I say? That's not a big deal. Well, I actually did not read line 25. Line 25, because we want to reverse suffix sums which corresponds to SF. That's not what I expected. Yeah, we're gonna debug it real quick because I'm actually late for lunch. So I have no intention of debugging it like a lot. The frequencies are 1, 1, 2, 2, 1, 1, 2, 2. Wait, once we reversed, we should actually take this, right? Am I right? It looks like I'm right. That's yeah, that's exactly the reason why you want to reverse in the first place, because then they are just in the same place, the same little place. Okay. Problem G, old floppy drive. Polycarp was dismantling his attic and found an old floppy drive. Oh, okay. Yeah, now I remember what floppy drives are. Round disk was inserted into the drive with n integers written on it. Polycarp brought the numbers from the disk into the A array, Turned out the drive works according to the following algorithm. Drive takes one positive number x as input and puts a pointer to the first element of the A array. Turns out the drive starts rotating the disk every second moving the pointer to the next element, counting the sum of all elements that have been under the pointer. Since the disk is round in the array A, the last element is again followed by the first one. Okay. As soon as the sum is at least X, the drive will shut down. Yeah, it's not difficult. I guess it's another implementation problem, which is kind of lame. But what else did you expect from B3 contest, right? We're not particularly quick, so I might call it a bad contest, right? Hmm. We should just compute the prefix sums and we'll be good. What is the point? What is the point? So now we have all our prefix sums. We should take X. What in remainder gets X divided by PS n. The sum of all arrays, and there will be Q full rotations, and remainder is what you have left. And then what you want to do is you want to say it gets a lower bound as, wait, our numbers are not necessarily positive, which is a huge mistake of mine to assume the opposite. Or actually, I don't know. I did not think it through. Yeah, I think I'm gonna have a lunch now and then come back to it later. So, and just a short pause in the recording for you, and I will be right back. Okay. So the idea is pretty much the same as in case with positive integers, but you have to be like a bit more careful. So instead of actually computing prefix sums, you want all positions when they increment, when they get bigger than before. So it's some sort of mono. No, I would call it monostack, but I guess monostack actually suggests that you're going to extract something, and here you don't. So Here I was also wrong. Should add +1 here. So now the sync is this gets computed once. Then you have that thing, which is the sum of all integers. We are going to no, this is not the sum of all integers. Want max prefix sum. Why? Because what was subtracted from x, to be able to finish like with one go, we have to cover all that remains in the full goes. So now we can divide by current sum, which is convenient as the sum of the entire array. By the moment we are here. And then you actually want to look for, now this got, I want to round up, that's the thing. Want to round up. I think I should do it like that. Now remainder is useless. No, I'm just going to like, yes, unfortunately, my favorite function diff is useless in this case. So I rounded up. Now I got number of operations in all these full passes. This is number of full passes we'll need, which is rounded up this difference. And it's number of passes. We got it back. Subtracted this now. X should be what we are looking for here. If we pass -1, we should get the first index. So no. +1 or -1 plus. Here we have plus. Oh, we have to print -1 if it's infinite. Well, that's not good. First of all, this should be only if x is positive. Only then we want this. It's annoying. This is actually annoying. How do we get 0? Jeez. Okay. Oh, we can actually get 0 here. Be more careful here. So this is a bit better. Is it? Is it better? What's wrong with them? 22. Understandable. How are you not found? Do I have to make pair explicitly because you can't sort for initializer list? This is incorrect. Oh, we did not count first thing. Apparently we did not count first thing. So here, instead of going to second, I think we just don't count it. Okay, so now we have like more than we wanted. Why? Like here, one single number is enough. I think this is a number and this is a query. So query 1. And prefix sums. Why is this begin first and not back first? We have some stupid ints. Let's see. This is a stupid int. Number of queries, number of test cases, index. I don't see any stupid ints. Maybe I just can't see. It happens. It's not a good sign. And it's running slowly like that. It's not a good sign. Wow. That's actually interesting. It's a runtime error. Isn't it because this got to the end? But it can't go to the end. because here, this is division of x by cs rounded up. Both x and cs are positive. So after we do this, x is negative. Not positive, not positive. Then we add NPS, and NPS is somewhere here with index at least 0. So it should, we should find it here, 100%. So that's not clear. What else can we do? This is prefix sum, but we only store values that increase prefix sum. So first is the value, second is the index, or more or less the index. Index plus 1 actually. CS is the current sum. CS always gets incremented by AI. If CS got greater than whatever was previous greatest prefix sum, and we place CS and corresponding index. And we see what is the prefix sum, the maximum prefix sum that we can have. Why? Because we can use this maximum prefix sum only once. And then if we don't use it, everything else should be covered by full terms. So we take our number x. Also have p and q for some reason. X gets decremented by this max prefix sum. The rest should be covered in full terms. Full terms cost CS. If x is greater than 0. Because if x got smaller than 0, then we can do 0 full terms, and we'll smaller or equal to 0, and we'll succeed just with prefix sum. And in this case, we're going to add 0 full terms here. If x is greater than 0, then this x should be covered entirely in full sums. If full sum is negative, then there is not much we can do. Oh, actually. Zero, yeah, divided by 0, hence the runtime error. Terrible. Yeah, I mean, like we were quite slow. Well, at least I had a lunch, right? But yeah, Galen Colin won the educational round 702. Congratulations to Galen. Oh, of course I can't post solutions. What I was doing. Even faster than Neil, Igor Loganov. That's impressive. Yes, these people solved everything like in 20 minutes. Just insane. Really awesome. Yeah, that's not great. What is second thread doing? Does he has like custom language video coming up? I'm not sure what this is all about. But yeah, we gathered the necessary penalty here, and we were quite slow as compared to our GM and not even GM friends. I don't like it. It's just stupid. That's why you are not a GM, because you're doing stupid things. Just to show off. if there's nothing to show off in div3 runs. Come on, be serious. So Matei got a good result. Fortunately, had the wrong answer. Well, actually, I'm in a good company with second thread, Matvey and Galen. Company of people who apparently can divide by 0 or do something else. Stupid and easy problems. Yeah, so this is it. This is it. Interesting thing. I actually had a meeting scheduled for 6, and I saw like, oh, that's the reason to write everything quickly, and then get to the meeting. But I guess I kind of don't have to hurry now because it got rescheduled. But whatever. So yeah. I don't think that we have to go over the problems again. Like this was pretty easy. And then here, I think I explained everything more or less clearly. So that's it for today. Thanks for watching. And I think I don't actually know when I'm going to see you next time. I guess in 2 days with div2 round. And notice that we have a Codeforces global rounds routine coming up on Sunday, of course, and cutting hairs. Not really coming up, but like that's a cool thing. I'm going to participate in this one. It was fun. So yeah, I think this is it for today. Thanks for watching. I hope this. Oh no. Yeah, I should do it like that. So I hope this helps you a bit. Maybe you'll see my solutions, you'll watch the video, and you'll get the idea. So yeah, thanks for watching, and see you next time. Bye-bye.